Sensation and Perception, Chapter 1, Introduction, Section 4. First topic is neural firing and action potential. And so there were two people, Sir Alan Hodkin and Sir Andrew Huxley, who worked in a marine bioassistant lab in Plymouth, England, and they found out from squid. They tested the nerve pulses along the axon, and so basically they would pierce the axon with an electrode to measure voltage. They used the squid because it has large axons and it was able enough to fit an electric node onto it, versus mammals have smaller ones and are too small to get an electrode in it. So basically, neurofiring, they found out, is electrochemical. The voltage increases along the axon caused by changes in the membrane of the neuron. So positively charged sodium, Na+, passes quickly into the axon from the outside. Then the membrane quickly changes it again in a way where it sends out the potassium ions, K+, out of the axon. And so there's a little diagram in the book denoting the axon where Na is going in and potassium is leaving. Then moving on, there's another subtitle called neuroimaging. And so basically it's a set of methods that generates images and structures of the brain while the person is living. So I'm going to go over those ones. First, an EEG, which is electroencephalography, is a technique with electrodes are placed on the scalp, and those basically measure the electrical activity in a population of neurons in the brain. What it doesn't do is pinpoint individual neurons or an exact area, but it does locate roughly a population of neurons. There's another method called you prick the skin or flash of light, which is event-related potential and ERP, and that is basically how the body and eyes react to a stimuli. Then there's an MEG, which is a magnecephalography, which entails a machine over the head which maintains good measure of timing a population of neurons while providing better idea of where it is in the brain that has most activity. There is also superconducting quantum intense devices, which are called squids, and that's that. Also, there's a CT, which is a computed tomography, better than an X-ray, but it has the same concept, which X-rays pass through the targeted space in your head, and it's like kind of like a slice of your brain, and it goes left to right or whichever direction it's going, and it shows the dense tissue absorbs more than the one that doesn't, and that's lighter then, and so it's a kind of a gray picture. And then it also measures the energy lost through the head, gives you a 3D picture at the end. Then there's another method called an MRI, which is a magnetic resonance imaging, powerful magnetic field that influences the way the atoms spin, and so there's a pulsating magnetic field to indicate the presence of specific elements in the tissue. Moving on, there's a little variation in that called an fMRI, and that's the activity of living tissue active in the brain, hungry for oxygen. So more oxygen means more blood. So there's the blood oxygen level dependent, the bold signal, measured by MRI devices. And then there is a PET, a position emission tomography technique, which is a safe amount of radioactive material that is introduced into the bloodstream. A camera detects the gamma rays emitted from the brain regions, and then also it's kind of logic behind it is the metabolic activity, oxygen 15 has like a very short half-life, and so it's just great and for hearing purposes because it is a more silent method. And so that's all the methods. And so just to kind of go over it again, for neuroimaging, there's the EEG, ERP, MEG, CT, MRI, and fMRI and PET. And you can kind of know the difference by just how the scans look like. For me, I remember it by the CT scans are gray, the PET scans are colorful because of the radioactive material, and then your other ones are a little bit different, like an EEG is more colorful. So definitely seeing the scans kind of helps you and mentally do that. And then also at the end of the chapter there's a little summary. And so this was section 4 of chapter 1, Introduction to Sensation and Perception.